Chapter 7 Integrals 12th Standard Cbse Ncert Introduction. Integrals. Integration as an inverse process of differentiation. Integration as an inverse process of differentiation. Integration as an inverse process of differentiation. Suppose we take two functions, capital F of x and small f of x. These two functions connected together such that d by dx of capital F of x is equal to small f of x. Suppose we take two functions f of x and small f of x connected together such that d by dx of f of x is equal to small f of x. This capital F of x is integral of f of x, small f of x, or this capital F of x is said to be antiderivative of f of x, small f of x. Hence we write integral f of x dx equal to integral small f of x dx is equal to capital F of x plus c, where c is some arbitrary constant. In the real number set. The symbol indicates integral sign. Hence, integral f of x dx is equal to capital F of x plus c, where c is arbitrary constant in the real number set. The symbol indicates integral sign. By varying the constant c, we get different antiderivative of a given function f of x. So note that by varying the arbitrary constant c, we get different antiderivatives of a given function f of x. So recall the introduction one more time. Integration is an inverse process of differentiation. Suppose we take two functions f of x and small f of x. These two functions connected together such that d by dx of f of x is equal to small f of x. The capital F of x is integral of f of x, or the capital F of x is antiderivative of f of x. Hence, we write integral f of x dx is equal to capital F of x plus c. C is an arbitrary constant in the real number set. The symbol indicates integral sign. So by varying the constant c, we get different antiderivatives of a given function f of x. Now we will learn some standard formulas in derivatives and antiderivatives. So d by dx of x power n plus 1 by n plus 1 is equal to x power n. Here n satisfying the condition is strictly not equal to minus 1. So differentiation of x is 1. Differentiation of sin x is equal to cos x. Differentiation of cos x is minus sin x. This minus sign is, suppose here minus cos x means the formula is only sin x. So d by dx of tan x, that is differentiation of tan x, is secant square x. Secant square x. Differentiation of cot x is minus cosecant square x. This formula is, suppose d by dx of minus cot x means the formula is cosecant square x only. The minus sign in front of cot x means answer is cosecant square x only. So d by dx of secant x. The secant x formula is secant x tan x. Cosecant x, derivative of cosecant x is minus cosecant x cot x. Cot x. Derivative of sin inverse x, 1 by root of 1 minus x square. Derivative of cos inverse x, it is minus 1 by root of 1 minus x square. And derivative of tan inverse x, it is 1 by 1 plus x square. So derivative of cot inverse x is minus 1 by 1 plus x square. Derivative of secant inverse x, 1 by x root of x square minus 1. X square minus 1. Derivative of cosecant inverse x, minus 1 by x into root of x square minus 1. So derivative of e power x is e power x, and derivative of log of mod x, that is 1 by x. So derivative of a power x by log a, it is a power x. A satisfying the condition is greater than 0. Also a is not equal to 1. This condition is very important. Now we move to learn some important formulae in indefinite, that is in integrals, that is antiderivatives formulas. So number one formula is the integral of x power n dx. So the formula is x power 1 plus 1 by n plus 1 plus c. So n satisfy the condition is strictly not equal to minus 1. So integral dx is x plus c. Integral cos x is a sin x plus c. Integral sin x is minus cos x plus c. Integral secant square x is a tan x plus c. Integral cosecant square x minus cot x plus c. So integral secant x tan x dx is equal to secant x plus c, and integral cosecant x cot x is equal to minus cosecant x plus c. Integral dx by root of 1 minus x square is equal to sin inverse x plus c. Then dx by root of 1 minus x square, we can use one more formula, minus cos inverse x plus c, and dx by integral dx by 1 plus x square. The formula is tan inverse x plus c, and integral dx by 1 plus x square, we also use one more formula, minus cot inverse x plus c, and integral dx by x root of x square minus 1. The formula is minus cosecant inverse x plus c, and in 14th one, integral dx by x root of x square minus 1. So the formula is secant inverse x plus c. So the left hand side is same. So we use here either minus cosecant inverse x plus c or secant inverse x plus c. And the formula number 11 and 12, the left hand side is same. Either we use tan inverse x plus c or minus cot inverse x plus c. And one more, the formula number 9 and 10, the left hand side is dx by root of 1 minus x square. Here also same, but the right hand side is different. Sin inverse x plus c minus cos inverse x plus c. Now the 15th one, e power x dx, e power x plus c. And the formula for 1 by x, integral 1 by x dx is log mod x plus c. And the last formula, a power x dx is equal to a power x by log a, where log a plus c, a satisfies the condition a is greater than 0, also a is not equal to 1. Suppose a equal to 1 means log 1, the denominator becomes 0. That is an indefinite form. Therefore, a satisfies the condition a is greater than 0 and a is not equal to 1. So, learning the formulae for the integrals with compared to the formula of derivatives. So, learn the formulas for derivatives and derivatives. So, comparing each other, then only our learning method is very easy. The formula over. Thank you.